has been incorporated. So that's what operating system. That's why I told that it's very difficult to define an operating system because it varies as the architecture varies. So we have defined the operating system from the perspective of its functionalities. So still, I didn't find any complete definition of operating system so far. So it depends on what kind of services you are expecting. We define in the same terms. That's all. So now we'll move to next concept called process. Okay. So process is actually one of the important part. It's actually a representative of your operating system. Okay. So now we'll discuss about what is process and what are the different process scheduling algorithms. Then we'll take few example algorithms and solve the problems. Okay. Now we have it's a very old question that what is the difference between program and process? Program and process, and we tell that program is something which is stored on disk or it is a set of instructions, and process is nothing but it's a program under execution. So, but let's analyze how this process is different from program. So, of course, program is set of instructions, okay, which are stored on disk. Okay. But whereas process is a program in execution or under execution. Now, most of us has misconception that process is nothing but a process which is executing on CPU. Okay, it is not necessary that if a process is executing on CPU, then it's a process. If it is residing in memory, then it's not a process. A process is something which is under execution. What do you mean by under execution? Under means if it is utilizing any system resources. Okay, so CPU is one of the resource. Okay, performing IO is one of the resource, taking resource, right? And memory is also one of the resource. So if the process is doing any one of this, or if it is only residing in main memory, or if it is doing some IO, okay, or if it is executing on CPU, then it is a process. So a process is nothing but it's a program in execution or under execution. What do you mean by an under execution? Under execution means it is holding any one of these resources. Holding any one of the system resources. Now, when program is loaded into the memory, it becomes a process, but there is still a difference between them. We generally call that program is active entity, program is a passive entity, and process is an active entity. It's an animated spirit of your code. What it means? For example, I have a C code here. I have written here if n mod 2 is equal to 0, then I will write printf even. Then I'll write else odd. This is my program P1. And I have another program P1. Here I'll write for I is equal to 0, I is less than equal to, for example, 10, I plus plus. Then here I'll write printf. So I'm writing short form PF as printf, percentile D, I. Now, the program may contain those set of instructions which may be executed or may not be executed. But at the point of execution, when you are executing this program, so either this line will be executed or that line will be executed, right? So either the process, when it is loaded into the memory, while it is executed, it will have either printf even or odd. So your process doesn't contains this control structures, okay? Whereas program contains this control structures. Moreover, program may contain these loops, but when it comes to the process doesn't contain loops. Instead of that, what this process will have? Process will have the value of I is displayed as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this what? Because it is residing in memory, we call it as an active entity, and it is the actual animation of what has been written. Okay, it's an instruction, and it's nothing but an execution of that instruction. Okay, that is nothing but a process. Okay, so process contains a lot of information, or whenever a process is a program is loaded into memory, okay, we call it as a process, and this process is a representative of operating system, and the designer of the operating system define process as a data structure. Okay, process as a data structure. So when we call this process as a data structure, it means every data structure has 4 parameters. Okay, one is it has a definition, okay, and it has implementation, okay, and it has operation, and it has. You take an example of stack, okay, attributes. Okay, we are aware with the stack data structure. Okay, now a stack has definition that it is last in first out data structure. The element which is sent last will be the element which is removed first, and it has its implementation. It can be implemented using arrays, or it can be implemented using linked list. And operation, we have generally 3 or 4 different types of operations, like push, pop, peek, get top, or peek, both are same, right? So these are set of operations it has. And attributes, it has top pointer, which always points to the top element of stack. So every data structure has 4 parameters. So when we talk about this process, and the designers of operating system, they told that process is defined as a data structure. Now let's talk about these 4 parameters with respect to process. So what is the definition of process? Just now we saw process is a program under execution. It's an animated spirit, locus of control. Okay, it's an active entity. How this process is implemented? Okay, process is implemented with the help of process control block. No, not process. It has been implemented like this. See, whenever a program is loaded into memory, okay, so that process will occupy memory, right? So this process contains code section. It is also called as text section. Okay. Then it has static section. Whenever you load any program, the code of the program resides in code section, and all static variables will they will be in static section, and you have dynamic data and you have static data or stack. The stack grows from bottom to top, and this dynamic data will grow from top to bottom. Okay. So this is empty space. So if there is a provision of accommodating more data, dynamic data, then dynamic section will be increased to the up level, right? And stack, if stack needs some space, then stack also grows dynamically downstairs. This is the way in which the process has been implemented. Right? When we talk about the operation, process has many operations. We can perform many operations on process. The examples are the operations on process are can be scheduled, or it can be scheduled, scheduling, or creating a process, and scheduling a process. Okay, dispatching a process, creating, so we and suspending a process, and we have suspension and resumption. Okay, terminate a process. Okay, there are many operations which can be defined on process, and process has attributes also. every process is associated with some information, right? Whenever any process is created, how operating system identifies this process? Whenever any process is created, a unique identifier is also created along with that. So an operating system will distinguish one process from another process depending upon this identifier. We call it as a process ID. So across the system, in the system, all the processes, okay, every process will have different identifier, process ID. So operating system uniquely identifies every process on a system by its process ID. So the attributes like process ID, okay, and what are the open files of a process, and all the information which is related with your process will be stored in a data structure called as process control block. Process control block. PCB, we call it as PCB. So it has information about process ID, okay, then all open files, all information. What do we think it's necessary, or what are the attributes of a process? All will be stored in this. All the attributes will be stored in process control block. Now we will see the state transition diagram for this process. When a program is on disk, it is not a process. When it is loaded into the memory, then it becomes a process. Okay. Then this it's a newly created process. Process gets created. So when a new process gets created, okay, now this process, a newly created process, will be given to CPU, but it is not directly. It's not generally directly given to CPU. There is one, okay, we'll talk about queues later on. So when a process gets created, now it becomes ready to run. Okay, it becomes ready to run. So after this created state, okay, it will be in ready to run state. When process is ready to run, okay, then you'll have CPU. If this process which is ready to run is given to CPU, then the state of the process, we call it as a running process. Running process. The event of taking a process which is in ready to run and giving it to CPU, okay, this is called dispatching. This is called dispatching. Okay. So now when this process is running, so two things may happen. Okay. Either this process will run to its completion and gets terminated. Okay. Terminate. And the event transition, we call it as exit. Okay. Or there is possibility that this process may perform some IO operation. When this process performs some IO operation, then the state will be in wait state, IO wait state. So this process will be in IO wait state how far till this IO completion has been happened. So when IO event is elapsed, when IO event is completed, then again will this process goes to running state or in ready to run state. Okay. So which one of the following is not a proper transition? Is it possible for a process to move from ready to run to running? Yes, this is a valid transition because of dispatching. Now, is it possible to move a process from waiting state or from IO wait to running? Is it possible for a process which is in IO wait to make it to ready to run? is it possible to make a transition from IO wait to terminate? Okay. Now, ready to run to running is a valid transition. Remember, whenever this IO event elapses, no process will directly go to again running. Why? Because as I have told you in multi-programming, there are more number of jobs, running in a they are loaded into the memory, and only one process will be running on CPU if you are talking about uniprocessor system.